My name is Alicia Kaysen. This is Project 5. So we're going to do a collections demo class. That is the name of my Java app. It's going to be the main app and the only class that we're going to have right here. Okay. So this program demonstrates the various functionalities of the Java Collections Framework, specifically focusing on the list interface in the array list implementation, as well as static methods from the collections utility class. The user is prompted to enter 8 unique single words. The user is also prompted to enter a word to search for the list. The program prints the initial list, its size, longest and shortest entries. It then prints the list after natural sorting, custom sorting, and shuffling. Search results, location or not found, are displayed. Results from additional collection methods are printed. Finally, it demonstrates converting the list to the array and back to a list, printing the contents of each array. So I basically just reiterated the project itself. All right, so we're going to start with a public class collection demo. The main method is the entry point of the application. It orchestrates the entire program flow, demonstrating various collections and collections functionalities. All right, so we have the command line arguments. So we're going to create a scanner object for the user input. Scanner equals new scanner in. This is the way that users are able to input their string options. So we're going to declare an array list of strings to store user inputs. We're going to use the list with the angle bracket string in between. Word list equals new array list. Then we're going to have the system to print out collections framework demo. Please enter 8 unique words. We're going to loop to allow the user to add 8 pieces of data to the collection. It ensures no duplicate entries are added, ignoring the case. So we're going to do that while loop. We're going to have the word list dot size. We're going to have it greater than 8. Less than 8. I do apologize. System.print enter word plus word list dot size plus 1. String word equals scanner next line dot trim. We're going to check if the word is empty. So we're going to implement that with that loop of if and the word dot is empty. System dot print word cannot be empty. Please try again. And then we're going to continue. All right, check if the word already exists in the list. It's going to be case sensitive. So we're going to hit the Boolean is duplicate equals false. For a string existing word in the word list, if existing dot word equals ignore case word, is duplicate equals true. And then we have a break. If it's not a duplicate, add it to the list. So another if statement is duplicate system.outprint. We're going to have the word is a duplicate entry. Please enter a different word. So it's going to let the user know that it is a duplicate word if they do put one in. We're going to have that else statement, word list dot add word, and that adds the original case word. So if it's not a duplicate, it's going to be added, basically. So initial list content, we're going to print the list using an enhanced for loop. So system.print current list. We're going to iterate through each element in the list to print it. For. And then we're going to have string s word list. We're going to have system.print word list. We're going to have an index of word list.size minus 1. So we can get that word list printed out. It's going to initialize the variables to find the longest and shortest entries. So it's going to start the string longest entry and then string shortest entry. Check if the list is not empty before finding the longest slash shortest. So we got that if statement word list dot is empty. Longest list equals word list dot get. Shortest entry equals words list dot get. We're going to iterate through the list to find the longest and shortest entries. Again, we got the for string s, and with that if statement s dot length And then we have the longest dot length. Is we're going to update the longest entry. We got another if statement here. S dot length with the shortest, and then we're also going to update the shortest entry. I do apologize. I got off of work, so I'm a little hazy. All right, we're going to print the number of entries, longest and shortest. So we're going to have to print out statement, total number of entries, plus the word list at the size. Then longest entry with the longest length. So it's going to tell us the characters. Shortest entry, shortest entry, and now the shortest length. And then list after natural sort. I apologize. Sort the list using collections.sort, natural order, alphabetical for the string. So it's going to be alphabetical order. So we're going to call that collections.sort. Sort list in alphabetical. Also, we're going to have another print, these print statements, list after custom sort length. The custom sort of the list by the number of characters in each string from longest to shortest. This uses a lambda expression as a comparator for concise code. So we're going to implement it here. As you can see, dot sort, word list, string is 1, string is 2, integer dot compare, says comparing. System dot, we're going to print out shortest list, longest to shortest by length. All right, list after shuffle. We're going to shuffle the list using collections.shuffle. And as we have it here, collections.shuffle. System is going to print out the shuffled list. You got to search the list. You're going to ask the user to provide a word to search for. We're going to prompt it when we print out the statement into a word to search for. And then we have string search word equals scanner. So that, again, that scanner is that input for the user. Dot next line trim. So it's going to search for the word that the user puts in again. We're going to convert the search word to lowercase for case sensitive comparison. So we got the found index equals -1. Initialize index to -1 not found. We're going to iterate through the list to find the word ignoring case. So we got that for loop going here. Int with the I index equals 0. And the index with the word list dot size. If word list dot get equals is ignore case search word. So we're going to store the index if found. So found index equals I, and then we're going to exit the loop so it's the break. We're going to output the location if found or a message if not found. Okay, so we got another if statement here. We're going to found index. System.print the word, search word, was found at index. Then we got the system out print of with the else statement, the word, search word was not found in the list. All right, we're going to demonstrate some other methods. We have a print line statement that's going to say that. We're going to implement at least 2 other static methods from the collection class. Method 1, collection reverse, and reverse the order of the elements in the specific list. So it's going to print out operation, collection reverse, original list before, and it's going to show the original list. And then we're going to call upon that collections.reverse so it can reverse the order of the word list. And you have to put word list here so you can reverse the order of the word list. And it's going to print out the statement list after reverse. So it's basically going to print out the reverse list. Okay. So method 2 is collection.frequency. It returns the number of occurrences of the specific element in the specific collection. To demonstrate frequency, we're going to add a duplicate word to the list temporarily. It will remove it after the demonstration. So to implement all of this, we got the string word to add for frequency equals word list to get. It takes the first word. Word list.add. Word to add for frequency is going to add a temporary duplicate. Then it's going to print out operations collection.frequency list with the temporary duplicate. And then we have int Frequency equals collections. Dot frequency, word list, word added to frequency. And it's going to print out the statement frequency of, word added to frequency, and then frequency. The frequency. So how many times? It's going to remove the temporary duplicate to restore the original state of the further operations. So then we're going to implement the word dot list remove in order to remove that duplicate. So word to add for frequency. And then we're going to convert the array list. So we're going to print out the statement converting the array list to let the user know. And we're going to convert the list to an array using toArray to provide a new string array of size 0 as an argument to ensure it returns an array of the correct runtime type. So we got string with the square brackets, word array equals word list dot toArray, because we need this to convert it, new string. And then system dot print elements of the array, arrays dot toString, and then we have the word array. Then we're going to convert it back, and we're going to print out that statement to let you know we're going to convert it back. So we're going to convert the array back into a list. Arrays.asList returns a fixed size list backed by the specified array. So we got lists. We're going to use those triangle brackets string new list from array equals array.asList word array. And it's going to print out elements of the new list from array. So we're going to also add the new list from array so that we can print it all out in the statement. We're going to close the scanner. So close the scanner, scanner.close. Okay. So let's, for minutes, it's just some more of my notes of the collections that I wrote. But let's go ahead and demonstrate this code. Let's take a little bit to build this time. All right, we're just going to bring it up here so we can see more. So please enter 8 unique words. So let's do word 1. We're going to put fun, sun, run, done, none. I know they're all rhyming, but it's easier to remember. Fog, fog. Should be my 8 word. Dog. Right, so as you can see, it says list after natural sort. It's sorted them: dog, done, fog, fun, log, none, run, sun. This is in the alphabetical order. And then the length is going to sort list longest to shortest. So the longest being done, shortest being sun, even though they're all 3-letter words here. And let me bring this up a little bit more so we can see more of it. Then we got sorted list. Oh, we read that one. So we got list after shuffle. So we got sun, done, none, fog, log, fun, dog, run. It shuffled it. And then it's asking me, I'm going to bring this up so we can see it from my camera of my to see it. So it says enter a word to search for. So let's search for dog. All right. So we have that collection start reverse. It says original list before reverse. Sun, done, none, fog, log, fun, dog, run. List after reverse. And it reversed it as you can see. Run, dog, fun, log, fog, none, done, sun. The tongue twister. Then we have the collection start frequency. List with a temporary duplicate. Run, dog, fun, log, fog, none, done, sun, run. And it did run twice, and it tells us right here frequency of run is 2. So we're going to convert the list to the array, the elements of the array. So we have the dog, fun, log, fog, none, done, sun, run. And converting the array back to a list. So the elements of the new list is dog, fun, log, fun, none, done, sun, and run. And then as you can see, process finish, and the code is exited out. So I hope that was a good demonstration of the collections frameworks of Java. Bye.